So in simplistic terms, it's a brain-controlled robot. I love to learn new things. I'm very inquisitive. I'm constantly asking questions and trying to figure out how things work. I also really enjoyed helping people. About a year ago, I was reading about Dr. Muotri in some scientific news, and I was very interested in the work he was doing. I found that his mini brains were really, really interesting, and I reached out to him and asked if I could get involved. And I also said that I had some robotics background, if that helped. So a brain organoid is basically a little mini brain. It's derived from stem cells. I did a lot of research into a bunch of different robots, and I determined, along with Dr. Muotri and Richard, that a quadrupod would be best to emulate sort of the neural signals, because it's more natural and it's also a little bit more simplistic. The Muotri lab collects all the data just with some electrodes underneath the organoid itself that just measures the electrical impulses. The data is inputted into the program itself, and it starts to parse that data. It graphs it, and it determines how active the brain is. And when the brain is more active, when there's more firing, the robot will go faster. The primary question being asked in this project is, how does external stimulus affect development? Without the robotic platform, there's no external stimulus. The organoid itself is not able to interact with the external environment. So we're giving a body to the organoid as opposed to just having the organoid contained in the Petri dish. We're allowing it to interact with the outside world. We're still working on the phase to connect the robot back to the organoid and have the robot affect and stimulate the organoid itself. Once we close that loop and we implement a real-time system in which we're not using that pre-recorded data, and the organoid can actually sit on top of the robot itself and directly affect the movements of the robot, we're hoping to perhaps have the organoids actually interact with one another through the robot. A lot of neurodevelopmental disorders, problems with brain development, such as autism, rely on some of these early pathways. And so through the robotic system, we're able to study these early developments and perhaps cure some of these mechanisms that are present in certain diseased brains. I feel very privileged. I'm very grateful for the researchers, and they're very knowledgeable and they've helped mentor me. And I'm very, very interested in robotics and biology, and I hope to make an impact and help other people. I could be a doctor, or I could work in neurology, something along those lines.